Forget what Hollywood taught you about space. It won't instantly freeze you solid. It will do something far, far worse. For decades, science fiction has painted a vivid, yet fundamentally flawed picture of space exposure. From 2001, A Space Odyssey to Total Recall, the cinematic trope of the instant freeze has become ingrained in our collective imagination. We see bodies stiffening, ice crystals forming, and life extinguishing with dramatic swiftness, usually accompanied by an ominous whoosh. This captivating visual spectacle is often designed for maximum dramatic effect. But in doing so, it completely obscures the genuinely terrifying immediate threats that would confront the human body in the airless, pressureless void beyond our atmosphere. This popular image of instant freezing is not just a misconception, it's a distraction from the truly excruciating and deadly sequence of events that would begin the moment you were exposed. So, if you wouldn't instantly freeze, what would happen to your body temperature? The notion of instant freezing comes from a misunderstanding of how heat is transferred. On Earth, we lose heat through convection, conduction, and radiation. In the vacuum of space, there's virtually no air. This means convection and conduction, the most efficient ways to shed heat, are almost entirely absent. Your body would primarily lose heat through radiation, much like a thermos bottle in a cold room. Imagine that thermos is filled with hot coffee. It will cool down, yes, but it won't instantly freeze. The temperature of space itself is often cited as near absolute zero, but that's the temperature of the particles in space, not a medium that can quickly draw heat from a large, warm object like a human body. Your body heat would radiate away, certainly, but this is a slow process. Depending on your clothing and exposure to sunlight, it would take hours, not seconds or minutes, for your body to cool down significantly, let alone freeze solid. Therefore, freezing is not the immediate danger you would face. Something far more insidious would take hold long before the cold became a fatal threat. The real, immediate, and utterly devastating danger in space isn't the cold, but the complete and utter absence of atmospheric pressure. On Earth, the air around us exerts a tremendous pressure on our bodies, about 14.7 pounds per square inch at sea level. Our bodies are perfectly adapted to this internal and external equilibrium. Remove that external pressure, and chaos ensues within milliseconds. Think about what happens to a balloon if you release it in a vacuum chamber. It expands until it bursts. The same principle, albeit more complicated and gruesome, applies to your body. The moment you are exposed to a vacuum, any air trapped inside your lungs would expand dramatically and violently. Our lung tissues, while elastic, are not designed to withstand such rapid and extreme internal expansion without external counterpressure. This sudden, explosive expansion can rupture the delicate alveoli, the tiny air sacs in your lungs where gas exchange occurs, within seconds. The air would then rush out, potentially damaging lung tissue and causing a pulmonary barotrauma, essentially an internal explosion. Trying to hold your breath would only make things worse, as the trapped air would have nowhere to go, increasing the likelihood of catastrophic lung failure, and air entering your bloodstream, leading to air embolisms that could travel to your heart or brain. But the respiratory system is just the beginning. The pressure difference also has a profound effect on the fluids within your body. Our blood and other bodily fluids contain dissolved gases and water. At Earth's atmospheric pressure, water boils at 100 degrees Celsius. But reduce the pressure significantly, and water boils at a much lower temperature. In the vacuum of space, your body temperature of 37 degrees Celsius is far above the boiling point of water at that pressure. This phenomenon is known as ebulism, and it's not the same as your blood boiling in a kettle. It means the water in your soft tissues, like your muscles, skin, saliva, and the whites of your eyes, would vaporize and turn into gas. This vaporization would cause your body to swell painfully, much like a pufferfish. Exposed skin, especially around the face and hands, would blister and expand noticeably. While your skin is elastic enough that you wouldn't literally explode, the swelling would be immense, painful, and severely disruptive to every bodily function. Imagine every cell in your body trying to turn itself inside out all at once. The lack of atmospheric pressure also presents catastrophic challenges to your circulatory system. Contrary to popular belief, your blood would not boil in the same way water boils in a pot. Your circulatory system is a closed loop, and your internal blood pressure, even without external pressure, is still higher than the boiling point of blood in a vacuum. However, the changes are still deadly. With the pressure differential, the gases dissolved in your blood would rapidly come out of solution, forming bubbles. This is akin to opening a can of soda. The dissolved carbon dioxide suddenly bubbles out. These gas bubbles, forming in your blood vessels, would impede blood flow and cause embolisms that could block crucial arteries and veins, especially those leading to the brain. More critically, without any external air pressure, your body would rapidly lose its supply of oxygen. The oxygen in your bloodstream and tissues, no longer refreshed by breathing, would quickly be consumed. Your blood would struggle to circulate effectively against the effects of embolism and gas embolisms. Within approximately 10 to 15 seconds, your brain, deprived of oxygen and proper blood flow, would cease to function, leading to rapid unconsciousness. This is why the 10 seconds in our title is so significant. That's roughly when you would lose all awareness, even as your body continues its agonizing deterioration. As if lung rupture, embolism, and circulatory collapse weren't enough, exposure to space means an immediate assault from harmful radiation. Our planet has a wonderful protective shield, its atmosphere and magnetic field. These layers absorb and deflect a vast majority of the sun's harmful ultraviolet radiation and the even more dangerous cosmic rays, high-energy particles from distant galaxies. In space, you have no such protection. The moment you are exposed, your skin would be bombarded by intense, unfiltered ultraviolet rays, causing severe sunburns almost instantly. Though the pain would likely be overshadowed by the other, more pressing horrors. Even more insidious are the cosmic rays. These high-energy particles can penetrate deeply into your body, damaging DNA and cells. While the long-term effects of cosmic radiation are cancer and other diseases, the immediate damage from intense exposure could be significant, contributing to cell degradation and even causing radiation burns on exposed tissues. It's an invisible, silent killer that compounds the already dire situation. To be clear, there have been a handful of highly documented cases of brief, accidental vacuum exposure. In these rare instances, such as test chamber accidents where individuals were rapidly repressurized within 15 to 30 seconds, some people have survived. But these are extraordinary exceptions, requiring almost instantaneous medical intervention and suffering severe, lasting trauma. These are not instances of survival in the conventional sense, but rather last-second rescues from the brink of certain death. Without such immediate, miraculous intervention, the consequences of vacuum exposure are invariably and unequivocally fatal. Your body's systems, from your respiratory functions to your cellular integrity, would rapidly succumb to the absence of pressure, the deprivation of oxygen, and the assault of radiation. Within seconds, your lungs would be compromised, your tissues would swell painfully from embolism, and your brain would shut down due to lack of oxygen. While you might remain biologically alive for a minute or two after losing consciousness, your ability to experience, react, or even hope would be gone. Surviving even a few seconds in a vacuum would be a horrific, torturous experience, and extended survival is utterly impossible without the vital life support systems of a spacecraft or a pressurized suit. The true danger of space is not its cold, but its profound and absolute absence of everything we need to live: air, pressure, and protection. It is the ultimate hostile environment, one that reminds us just how delicate and perfectly adapted our bodies are to the tiny blue bubble we call home. If you want to unravel more of the universe's terrifying truths, click on the video now appearing on your screen.